Alright, this is our second video on this lesson about graphing rational functions. We're picking up here with number 5, and number 7 is what we're going to do for this video. Check it out. Alright, so here we go on number 5. First of all, X-Intercepts. How do we find the X-Intercepts? Well, you set the numerator equal to 0 and you solve. So if I do that, that's going to be 1 minus 3x equals 0. Subtracting 1 from both sides will give me negative 3x equals negative 1. Dividing both sides by negative 3 is going to give me x equals positive 1/3. Because a negative divided by a negative is a positive. So since this is the x-intercept, that means this value is the x value. So 1/3 comma 0. And let's graph that. So we go to 1/3 on the x-axis and put a dot. Now, how do we find the y-intercept? Well, excuse my throat clearing. I don't know what's going on with me. If I want to find the y-intercept, what you do is you substitute 0 for x. You let x be 0. So in other words, I'm going to put in 0 here and here. So this is going to become 1 minus 3 times 0 over 1 minus 0. Well, guys, negative 3 times 0 is just 0. So that's gone. And subtracting 0 doesn't do anything. So it's really quickly just becomes 1 over 1, which is 1. So that's the y-intercept that we're finding. And if the y-intercept is 1, then that means that 1 is the y value. So 0, 1. So let's graph that as well. 0, 1 would be right there. Next, vertical asymptotes. How do we find the vertical asymptotes? You set the denominator equal to 0 and you solve. So 1 minus x equals 0. Subtracting 1 from both sides, or you know what, now I'll do it this way. Subtracting 1 from both sides, so that's negative x equals negative 1. Divide both sides by negative 1 and you get x equals 1. Alright, so this is how you find a vertical asymptote. So put x equals 1. Don't just put 1, put x equals 1. Okay, and how do we find a horizontal asymptote? Well, the horizontal asymptote is the one where you have to look at the degree and decide which one of these three situations you're in. If the numerator degree is less, then y equals 0 is the asymptote. If the numerator degree is equal to the denominator, then we do y equals a over c, where a and c are the leading coefficients. If the numerator degree is greater, then there is no horizontal asymptote, though there might be a slant asymptote, which we'll talk about during another lesson. So which situation are we in here? Well, the top degree is 1. You see it says x. The bottom degree is also 1. So since the degrees are the same, we're in this middle situation where we're going to use the leading coefficients. Now be careful. The leading coefficient is not 1. You really should probably rewrite this in standard form. Instead of 1 minus 3x, that would be negative 3x plus 1. Instead of 1 minus x, standard form would be negative x plus 1. Okay, so hopefully now you can see what the leading coefficients are. Negative 3 and negative 1. So that means that the horizontal asymptote will be y equals and negative 3 divided by negative 1. Maybe I'll show another step. but that equals positive 3. So the horizontal asymptote is y equals 3. So let's go ahead and graph both of these asymptotes. So I need a vertical asymptote at 1 and a horizontal asymptote at 3. I'll do that off camera. Alright, so there are the asymptotes. Now, before we can answer about the domain, range, increasing and decreasing intervals, we need to go ahead and come up with a table of values. So students always ask me, how are you picking those values, Mr. Burton? Well, there's a certain amount of personal choice involved, but look at the vertical asymptote. You definitely want to have values on both sides of the vertical asymptote. Alright? And I want to fill up this chart. Let's use at least all 7 values. Okay? So, for example, let's do -2 and -1. Actually, strike that. Let's do -1. Okay, because that'll show me what's happening in here. You know what? I guess I already have a decimal. I was going to say I want a decimal, but we already have 1/3, comma 0. So I'll go ahead and do -2 and -1 because we've got these. Now, I like to have a decimal on both sides of the asymptote so I can see what's happening close up. I'm going to go ahead and count this as my decimal, but on the right hand side I want to see what's happening at, let's say, 1.5. So let's get that in there. 1.5 is super close. And also let's do like 2 and 3. Alright, that's a lot of points. Let's graph those so far and see what we have. Now I feel like filling out this chart. So we have 1.5 and 2 and 3. I'm going to add 1 point to each side of this list. So let's do 4 and let's see what's happening at -0.5. Oh, not -0.5. Let's see what's happening at 0.5. Okay, or 1/2, whichever we want to call it. Okay, so this will give us a nice spread of points to picture what's happening. I'm going to evaluate these off camera, but let me just show you a couple of things though. I'm going to use the calculator, alright, but alright, so the function here is 1 minus 3x over 1 minus x. Okay, let me just pull this over a little bit. Alright, 1 minus 3x over 1 minus x. Let's take a quick look at this. I'm going back to auto mode for now. So that's how we can get to this table of values. Let's go ahead and use the calculator to find all of the integer values. Okay, the -2, -1, 2, 3, 4, everything except for the fractions we can now get just by scrolling around. So I'm going to do that off camera. Don't forget, if I want a decimal out of this, I can just highlight it and hit the toggle key, and that tells me 2.3. So this is -2, comma 2.3. For example. Alright, so here I've gotten all the integer values off that table, everything except for the fraction and the decimal. So how will I get the fraction and the decimal? Well, hit your table button again, come back to here, hit enter. I would recommend using the Ask X feature. So I'm going to go down here, but instead of choosing auto, I will choose Ask X. Now what that does is I can type in whatever I want. So if I want to do 1.5, I will just type in 1.5 and hit enter. Oh, 1.5, that's 7. Put that on my chart. I want to know what happens at 1/2. So I could just type in 1/2. At 1/2, I got -1. Okay, so the Ask X mode is very helpful if you have to deal with fractions or decimals. Alright, so now I have all these points. I can't wait to graph them and get a picture of what this function is going to look like. But I think I will plot these points off camera. Alright, I've now plotted each of these points. Drum roll, please. Brrr, psh. This is what those points look like once graphed. And this display of points gives me a pretty good idea of what the graph looks like. Something like this right here. Alright, so that branch should look a lot like that. And then this one should look something like this. Okay, and there you go. So now let's go ahead and talk about the domain and range. The domain is the x values of the graph. So we're looking, what are all the x values from left to right? Well, this graph goes left and right forever, so all x values are represented except for the vertical asymptote at 1. So that's why the domain, I can basically give the domain for the left piece first, and that is -infinity to 1. Okay, you might have thought -infinity to -infinity because this goes down forever, but we're only interested in x values. So x value wise, this arrow right here is -infinity, and x value wise, this is at 1. Okay, because it's this is the asymptote. Now the rest of the domain, so union, and we pick up right from here after 1. So I put 1 to positive infinity. Alright, now the range is very similar, but the range is the y value, so bottom to top. So the range includes y values from -infinity to 3. And then it picks up from there and goes from 3 to infinity. Alright, I started making 8. 3 to infinity. Alright, now let's talk about increasing and decreasing intervals. We have to trace the graph from left to right. And as we go from left to right, look what happens. It goes down. So that first branch is a decreasing interval. So that's decreasing from -infinity to 1. Now, what about the other branch? From left to right, this also goes. Alright, it's decreasing. So, from 1 to infinity is another decreasing interval. This graph has no symmetry. It's neither odd nor even. I see rotational symmetry, but the center of rotation is 1, 3. It only counts as odd if it rotates around the origin. So neither. Okay. Alright, that's it for problem number 5. Yeah, this video is 15 minutes long, so I'm going to go ahead and stop this video here, even though it's only one problem. Alright, I'll pick up the next video with number 7.